Hello, this is Ronald G. presenting as a summer intern for NASA. Over the summer, I helped create an antenna with Raspberry Pi and an NVNA. I did this with my mentor, John Doty. So this is the outline of the PowerPoint. I talk about the goal of the project. I talk about antennas. I talk about how I have everything set up. I talk about programming in Mathematica. I test a device, and I summarize my PowerPoint. So this is the goal of the project. It is to connect the Raspberry Pi with an NVNA. And then after that, I can read data from the NVNA into the Raspberry Pi. And what I do with that data is I graph that data. So this is how antennas work. It takes information and turns it into energy. Takes this energy and turns it into a radio wave, which it sends to other antennas. And it can also receive these waves. So the radio waves are called electromagnetic waves, and they have parameters such as amplitude and phase that can be analyzed. So this is how I built my platform. First, I set everything up, which is the NanoVNA, the Raspberry Pi, and a device. After that, I had to do a bit of programming, which is to use Mathematica and also use Mathematica to graph. So this is a diagram of my setup. The Raspberry Pi sends commands to the NanoVNA, and the NanoVNA takes these commands and sends waves to scan the device, which gives it output, and the NanoVNA reads the waves that have changed after moving through the device, and it sends that data back to the Raspberry Pi. And this is the image of my setup. This is the NanoVNA. So it sends a sine wave through port 0. It sends a wave through port 0 that either comes through port 1 and has some reflected back to port 0. And they're both sine waves too. They just have different amplitudes and phases. And this is the Raspberry Pi, which is a very small computer that is used for programming, which is what we're using for this project. So when I got my stuff, the Raspberry Pi could not open because the SD card was not working. So what I did is I reset that card with software called Raspberry Pi Imager. And after that, I had the Raspberry Pi working, so I installed Mathematica. And what I did is I opened the terminal, I made sure everything was updated, and I typed a command to install Mathematica. Once I had Mathematica installed, I had a few things I had to do, which is to send commands, receive data, and then split the data into things that are useful, and then I plot that out. So here is how each function helps each other functions. Is a flowchart. When I was programming, I had an issue, and that it was fine when I was scanning very little points, but once I had much more points, there was some times when the program was unreliable. And we were stuck on that for a while, but we realized that Mathematica can only read so much of the buffer that the NanoVNA and Mathematica, or the Raspberry Pi, shares. So what we did is we made Mathematica read the buffer multiple times until NanoVNA said they were done. And so here's a little bit of the code that we used to do that. We graphed the information because they were already in lists. They were in pairs, and Mathematica had a built-in function to graph out pairs. So this is a graph. So here are some other functions. The dynamic module is visual. You can type in how much you want to scan. And the VNA check is also a check to see if the device that's connected to whatever your program is running on is actually the NanoVNA. And here is another function that I did, and it's to scan more than once, but it doesn't work well with the graphing. So I uploaded my work onto GitHub, and I also made a more organized notebook from my last one. And you can see that it's right here. The link is right here if you want to download it. So finally we do a test. And so the NanoVNA itself does not give important information like reflected and transmitted power and phase. So it gives x and y values in this trigonometric equation that can be used to find those values. Here is what we used to test our program. This is a device sent to me by my mentor, John Dowd. And these are the parameters, so yeah. And these were the results. This is a graph going up to 3.14, going back up, going down to 3.14, going back up. This is power, and this is very small power that is transmitted back. And so the summary, we connected the Raspberry Pi to the NanoVNA. We took scan data from the NanoVNA and we turned that into a graph. And thank you for watching.